Okay, 2.2, day one and 2.1, we graphed parabolas in vertex form. Now we're going to graph parabolas in standard form. Standard form is in this format right here. It's f of x equals ax squared plus bx plus c. This is an example of a function in standard form or a quadratic. Just like in the previous format, this is the a value. The a still tells you whether there is a vertical stretch or shrink or if there's a reflection of the x-axis. If you're graphing in standard form, the two pieces of information we want to have are the vertex and the y-intercept. To find the vertex, we use a formula called negative b over 2a, and then that tells us the x value of the vertex. We take the x value, we plug it back in the original equation to get the y value, and that will give us the vertex. The y-intercept is the y value you get when you plug in 0 for the x. If you plug in 0 for x, you end up with c. So the c value is always your y-intercept. So on this equation on the right, the a value is the one with the x squared. So it's 5x squared. It's positive 30x, so the b value is 30. It's minus 12, so the c value is negative 12. We could use the formula to find the vertex, and we will in a moment. The y-intercept is always 0, comma, the c value. The c value is negative 12, so if I wanted the y-intercept of this graph, it would be 0, comma, negative 12. Okay, let's try this for real on this function here. It is in standard form. It says 3x squared minus 6x plus 5. Yeah, I'm going to go ahead and identify the a, b, and c value so I can use the formula. So since it's 3x squared, the a value is 3. Since it's minus 6x, the b value is negative 6. Since I have plus 5 as my constant, my c is positive 5. Okay, the formula to find the x-coordinate of the vertex is negative b over 2a. For the vertex, we often use an h here and a k here. So sometimes we say h equals negative b over 2a. So let's find h. H is the x-coordinate of the vertex. It's a fraction. It's negative b. These are my values over here I'm going to use for the formula. The b value is negative 6. I'm going to do negative 6. If I do negative 6, it switches it to positive 6. The denominator is 2 times the a value. The a value is 3, so I'm going to have 2 times 3. I'm going to go ahead and simplify this, and this is going to give me the x-coordinate of the vertex. 2 times 3 is 6. 6 divided by 6 is 1. So the vertex is going to be 1, comma, something. H is the x-coordinate. Okay, to get the y value, I'm going to take the 1, since this is the x value, and plug it into this original function to get the y value. Okay, so notationally, I'm going to say f of 1. You could also say k equals, some people like to write y equals. Okay, the original equation is 3x squared minus 6x plus 5. Since I'm finding the vertex and I know the x coordinate's 1, I'm going to plug the 1 in for x. 1, 1. And I just have to evaluate it. Okay, when you evaluate it, just make sure you follow your order of operations. I do need to do the exponent first. So 1 times 1 is 1. So this is 3 times 1. 6 times 1 is 6 plus 5. 3 minus 6 plus 5. You can add these up in your head. You can use your calculator. Either way is fine with me. 3 minus 6 is negative 3. Negative 3 plus 5 is 2. Okay, so my vertex is 1, comma 2. Okay, I'm going to go ahead and graph 1, comma 2 on my graph. 1, 2 is up here. Okay, now this is the vertex. My a value is positive, so it's going to open in the upwards direction. I'm okay with that. I'm going to go ahead and draw the axis of symmetry. The axis of symmetry divides the graph in half. I don't have a parabola yet, but the vertex is the middle of the parabola, and it's a vertical line, so I can still draw the axis of symmetry or the line of symmetry through the vertex. The axis of symmetry is a vertical line, so it must be of the format x equals. To figure out what x equals, I can either look at the graph or look at the vertex. It's intersecting the x-axis at 1, so it's x equals 1. Or if I look at the vertex, the x coordinate is 1, so I could tell it's x equals 1 from there. Both ways are correct. Okay, part C, the y-intercept is. The y-intercept is 0 comma something. So if I plug 0 in for this and this, I am left with the C value. So since C is 5, my y-intercept is at 0, 5. Okay, I'm going to graph 0, 5 on my y-axis. This is the y-axis. 1, 2, 3, 4, 5. Okay, the last step, I'm going to plot the point symmetric to the y-intercept and any additional points. This is the axis of symmetry, it divides it in half. So if there's a point on the left side of the axis of symmetry, there must be a corresponding point on the right side of the axis of symmetry. So this is 1 away. So on the other side, the right side of the axis of symmetry, I'm drawing another point. Okay, this is enough information to get a decent parabola. So I'm going to sketch it. It should be curved because it's a parabola. Okay, if I want to kind of check my answer, if I go back to the original equation, the A value tells me if there's a vertical stretch or shrink. There's a vertical stretch of 3. So if I start from the vertex, if I go right 1, up 3, left 1, up 3, I should have been able to get a point on the graph, and that matches up with the information I have previously found. Okay, you're going to go ahead and try the practice problems. If you feel like you're going to, if try them on your own. If you get stuck, unpause the video, and then I'll go through the problems. Okay, so for the first one, A is 2, 2x squared minus 8x, B is minus 8, C is positive 6. Okay, for the vertex, remember H equals negative B over 2A. You don't need to write it every time, but you got to remember it. Okay, so negative B. B is already a negative 8. If I do a negative 8, it's going to switch it to positive 8. 2A. Okay, let's simplify that. 8 divided by 2 times 2 is 4. So the x coordinate of the vertex is 2. So my vertex is 2 comma something. To get the y coordinate, I'm going to substitute my x value back into the original function. Since this function is called g, I'm going to call it g of 2. You can also say y equals, you can say k equals. It's up to you. Okay, now the formula is 2x squared minus 8x plus 6. So 2x squared minus 8x plus 6. For the x value, I'm plugging in the 2 that I just found is the x coordinate of the vertex. Okay, and then remember to respect your order of operations. 2 squared is 4. I'm running out of room. I'm going to go sideways. 2 squared is 4. 8 times 2 is 16 plus 6. 8 minus 16 plus 6 is negative 8 plus 6. I get negative 2. So my vertex is 2 comma negative 2. Okay, I'm going to go ahead and graph it before I forget. Okay, and then I'm going to sketch my axis of symmetry. I do it right away because otherwise I lose track of which one's which. Okay, so I have a vertex, I have an axis of symmetry. Let's look for the y-intercept. The y-intercept is the number at the end, just like on a line, or it's the C value, which is this one right here. So the y-intercept is 0, 6. Okay, I'm going to graph 0, 6. 0, 1, 2, 3, 4, 5, 6. Now there should be a symmetric point to the y-intercept. This is the axis of symmetry. Since the y-intercept's on the left, there should be a matching point on the right. It's exactly 2 units away, so I'm going to go 2 units on the right and do the same. Okay, now this is enough information to get a good graph. However, you can always check your graph by checking your A value. Your A value tells you if there's a stretch, a shrink, or a flexion of the x-axis. Since there's a 2, there's a vertical stretch of 2. So if I start from the vertex, if I go right 1 up 2 and left 1 up 2, I should get 2 other points on the graph. Those seem to match up with the points I have. So I feel like I did it right. Now I'm going to go ahead and sketch my graph. Make it look curved, put arrows at the ends. Okay, I'm going to 2. Pause if you want to try it first. Okay, for 2, I have x squared. I need an a value. X squared is the same as 1x squared, so I'm going to say a equals 1. plus 6x. B is positive 6. C is positive 2. Okay, let's go ahead and find my vertex. H equals negative B. B is 6 over 2A. Okay, let's simplify it. Negative 6 divided by 2 is negative 3. So my vertex is going to be negative 3 comma something. Okay, to get the y-coordinate of the vertex, I'm going to plug the negative 3 into the original function where the x's are. Since the original function is called h, and even though it's a little confusing, I'm going to go h of negative 3. Okay, the original function was x squared plus 6x plus 2. Okay, for x, I'm plugging in the x coordinate of the vertex. Negative 3, negative 3. Okay, negative 3 squared, negative 3 times negative 3 is positive 9. 6 times negative 3, negative 18 plus 2. 9 minus 18, negative 9. Negative 9 plus 2 is negative 7. If you keep messing up on the last step, just use your calculator. I would rather you do the algebra right and not stress about the arithmetic. Okay, let's graph the vertex before we lose track of it. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. Okay, down here. I'm going to draw the axis of symmetry before I lose it. Did they ask me what the equation is? Hold on, let me read the directions. Oh, they did. Hold on, let me go back and write the axis of symmetry. So the axis of symmetry, I'm going to use AOS as an abbreviation. It starts with x equals because it is vertical. And what is it passing through? It's passing through x equals 2. So I'm going to say x equals 2. Okay, so now let me make sure I write the axis of symmetry for this one. I'm going to do AOS is lazy way. Okay, vertical, it's x equals. It has to say x equals. It's a line. It needs to be an equation. It's x equals negative 3 because it's passing through the negative 3 on the x-axis, or because the x coordinate of the vertex is negative 3. Okay, what else do I need? Y-intercept. Y-intercept is the c value or the number at the end. So c is 2, or it's this number right here. Y-intercept 0, 2. 0, 2 is up here. Okay, now this point is on the right of the axis of symmetry. There has to be a corresponding point on the left over here, but I want to make it equal. So this is 1, 2, 3, 1, 2, 3. It should look even. If it doesn't look even, it's not right. Okay, now 3 points is enough. I don't have to do extra information. However, I'm going to use the A value to confirm that I've done it correctly. The A value is 1, so there's no stretch, there's no shrink. It's going to follow the normal pattern for a quadratic function, which means some vertex I go right 1, up 1, left 1, up 1. If I go right 2, up 4, I can get more points. 3, 4. There. And if the points look like they're lining up, then I probably did it correctly. These look pretty lined up. I'm going to go ahead and draw my parabola. I curve it. I put arrows at the ends. Okay, one more for today. Again, if you're good, pause it. Just check your answers at the end. Okay, A, it's negative 2x squared. A is negative 2 plus 4x. B is positive 4 plus 5. C is positive 5. Okay, vertex formula. H equals negative B over 2A. Okay, so I got negative 4 divided by negative 4, which is positive 1. So what's my vertex? My vertex is going to be 1 comma something. To get the y coordinate, I take my 1, I plug it in the original equation. G of 1. Okay, negative 2x squared plus 4x plus 5. Everywhere I see x, I plug in my 1, 1, 1. Respect your order of operations. Do the exponent first. 1 times 1 is 1. 4 times 1 is 4. So I get -2 plus 4 plus 5. -2 plus 4 is 2. 2 plus 5 is 7. So g of 1 is 7. So my vertex is 1 comma 7. Okay, let me go ahead and graph that. Okay. What else? Axis of symmetry. Let's draw it in. Vertical x equals 1 because this is a 1 right here. Okay, what else? Y-intercept. Y-intercept is the C value, which is 5, or this value. And I write it as an ordered pair because it is a point. Okay, 0, 5, 1, 2, 3, 4, 5 is up here. Okay, let me find the corresponding point. This is axis symmetry. This is on the left. There has to be a matching point on the right. Okay, and let me just check with my graph. In the front, the A value is -2, so there's a reflection. It's going down. Looks like it's going down. It's going down 2 on each side. So if I go right one down 2, I should be on the parabola. If I go left one down 2, I should also be on the parabola. If you want to add an extra point, we normally go 2, 4, but since it's stretched by 2, we actually go 2 down 8. And I do the same on the opposite side. Okay, and then make sure you draw in your lovely parabola opening in the downwards direction.